Welcome to another training session on PLC programming. This is the part 2 of the last PLC programming tutorial. In first part, we have learnt how we can detect the size of boxes using two beam sensors. If you haven't seen the part 1, link for part 1 of this tutorial is given in the description box below. In today's tutorial, we will see how we can segregate boxes and transfer big boxes on other conveyor. Before starting, I would like you guys to please subscribe this channel and press the bell icon to get the notification of the upcoming video tutorials. Before going further into this tutorial, let's see a message from the sponsor of this video. Today we will discuss the ECAM function of the Wecon PLC. ECAM function allows to program one or more servo drives to control motion in the multiple axis. As name suggests, electronic cam function works similar to mechanical cams, but it more flexible and accurate. Cams convert ordinary shaft rotation into a more complicated pattern of motion. This is accomplished by keeping one or more followers in contact with the surface of a rotating cam. The follower may move as a slider, reciprocating in a linear direction, or as a rocker. This cam follower motion patterns can be achieved by the servo motors and ball screws. Problem with these mechanical cams is that, if we have to make small changes in the pattern of movement of cam follower, we have to change the cam every time. On the other hand, with the ECAM function, these changes in the cam follower motion pattern can be achieved by modifying the ECAM parameters. There is no need to modify the hardware setup. Using this ECAM function, we can program multiple axes of the machines easily, for wood, table cutting, stone slab cutting, metal sheet cutting. ECAM will be more flexible, programmable, more precise and accurate. Let's quickly start today's tutorial and see the mechanism to divert the big boxes on the other conveyor. We have installed here a pneumatic cylinder with a pusher. This cylinder is activated by the Y3 output of the PLC. When PLC output Y3 activates, this pusher cylinder will extend forward and transfer boxes onto the next conveyor. The next challenge is that we have to detect when the big box comes in front of this pusher mechanism, so that the pusher mechanism activates exactly when the box comes right in front of the pusher. To check this, we will install a cam on the conveyor roller. This cam have an edge extended outwards. To detect this edge, we will install a metal proximity sensor. When this conveyor runs, its roller will rotate this cam, and whenever the cam edge comes in front of this sensor, its signal will be picked up by this proximity sensor. We can count the pulses of this sensor using a simple counter in the PLC. The number of counted pulses can give us an idea how much this conveyor have traveled, and what is the location of the box on the conveyor at any point of time. For example, when the box is detected by the height sensors, we will start this counter and stop this counter when it reaches the pusher mechanism. You can see that it takes 3 pulses for the box to reach the pusher mechanism. We will implement same logic in the PLC programming. Let's see the PLC programming for this pusher mechanism and this counter mechanism. In ladder number 12, as you can see that, we insert the normal open contact Y2 of the red light. When big box is detected, this contact will be closed, and this latch on the pusher start bit M2. In next rung number 17, when the M2 pusher start bit is on every rising edge signal of the cam sensor X3, the counter C0 is incremented by 1. In the next rung 22, when the counter C0 value reaches 3, its normal open contact closes and turns on the pusher Y3. In parallel, it will also turn on the timer T0 for K5 time. So, the pusher output will stay on for 500 milliseconds. When the T0 timer is over, it will reset the counter C0 in the last rung, and on the same time its normal close contact opens up, and turn off the pusher start bit, and pusher output Y3 goes low, and pusher comes back to the home position. Now let's upload the program in the PLC and see how does it works. As soon as we trigger the start bit M0, the roller conveyor Y4 starts running. As the big box comes in front of the sensor X1 and X2, the red light Y2 turns on, indicating the detection of the big box. As you can see that now the pusher start bit M2 is turned on in the rung number 12. In the next rung, the C0 counter is counting the rising edge signal coming from the cam sensor X3. When the counter value reaches 3, its normal open contact in the next rung will closes and turns on the pusher cylinder Y3. The pusher cylinder gets extended outwards and transfer box onto the next conveyor. When the timer T0 is over, it will reset the counter C0 current count value back to 0 in the last rung. Same time it will turn off the start pusher bit M2. It will reset everything and ladder is again ready for the next cycle. So, this is how we can make a simple logic using a cam sensor to track the position of objects on the moving conveyors. For more accurate tracking, we can install an encoder as a feedback instead of the cam sensor. Do visit the Wecon Technologies website. They are manufacturer of most reliable and affordable devices regarding automation industry. Wecon Technologies is the manufacturer and supplier of PLCs, HMI, frequency inverters, and servo motors and servo drives. Wecon Technologies can provide best hardware and software solutions for your next project. That's the end of today's video. Please share, like, and subscribe this channel, and do check out sponsor of this video. Link is in the description box. Till next time, take and goodbye.